Hello and welcome to Software Engineering Know-how. We are going to learn microservices. So the topic is decompose a monolithic application into a microservices architecture. So in this video, you will learn what is a monolithic application, what are microservices, and the characteristics of monolithic application and the microservices application. Benefits of decompose a monolithic application into a microservice architecture. What is monolithic architecture? A monolithic architecture is an architecture where all components for an application are co-located within a single unit. This unit is typically constrained within a single runtime instance of the application. A monolithic application is typically an application system in which all of the relevant modules are packaged together as a single deployable unit of execution. So in the diagram below, you can see a typical monolithic application where it is having multiple services and it is having its own application logic, data access layer, application instance, and it is having a centralized database which is being accessed by all the services through the data access layer, and this application is being accessed by the client through the client UI. In continuation to what is a monolithic architecture, so a monolithic application is a traditional software architecture in which all the components and the functionality of an application are tightly integrated into a single code base and deployed as a single cohesive unit. In a monolithic application, there is usually a single database that serves the entire system, as you saw in the diagram, and all the software components, including the user interface, business logic, and data access layers, are part of the same application. These systems start small but tends to grow over time to meet business needs. At some point, as new features are added, a monolithic application can begin to suffer from the following problems. So the problems are the individual part of the system cannot be scaled independently because they are tightly coupled. It is hard to maintain the code because of tight coupling and the hidden dependencies within this. Potentially difficult to understand and maintain due to the application size and complexity. Testing becomes harder, increasing the probability of introducing security vulnerabilities. The architecture is tied to a single technology stack, which limits innovation in new platforms and SDKs. So you can see this diagram how the monolithic application looks like. Here are some key characteristics of monolithic architecture. So the single code base, all the code that makes up the application is written in a single code base, typically organized into modules or classes. Tight coupling, components within the monolith are tightly coupled, meaning they depend on each other, and the changes in one part of the application can affect other part. Shared database, monolithic application typically use a single centralized database to store and retrieve data for the entire application. Scalability challenges. Scaling a monolith application can be challenging because all components must be scaled together. Even if only a few components experiences increased load. So the next is deployment complexity. So deploying updates or changes to a monolithic application can be complex and risky, as changes may require the entire application to be redeployed, potentially causing the downtime. The next is technology stack. So monolithic applications typically use a single technology stack, including specific programming language and frameworks throughout the application. And then the next one is development teams. So development teams often work on the same code base. There's no separate code base, which can lead to coordination challenges and conflicts in larger projects. Coming to the microservices. So, what are microservices? So, microservices is an architectural style and approach to designing software applications as a collaboration uh, and collection of a small, independently deployable services, each responsible for a specific business capability or function. In a microservice architecture, a large and complex application is broken down into a set of loosely coupled, fine-grained services that communicate with each other through well-defined APIs, the application programming interfaces. And then each microservices can be developed, deployed, and scaled independently, which offers several advantages in terms of scalability, maintainability, and flexibility. You can see a typical microservice application in the below diagram, how it looks like. So, how it is having like multiple microservices, uh, a system is having, and each microservice is having its own separate database. It is not depending on a single centralized database, and how the client UI accesses uh, the each microservices. So it gets only one URL, and that URL of API gateway, and through that it accesses the APIs. API gateway routes the actual call to the respective microservice, and then it goes and fetch the database or store the database in from the respective service database, and it can make the external or remote service call also. Then continuation to what are microservices. A microservice architecture consists of services that are small, independent, and loosely coupled. Each service can be deployed and scaled independently. Because each service is independent, they can use different technology stacks, frameworks, and SDKs. It's common to see service rely on REST calls for service to service communication by using well defined APIs instead of remote procedure calls or other custom communication methods. Microservices architectures are technology agnostic, but you often see containers or serverless technologies used for their implementation. Continuous deployment and continuous integration, CI/CD, is frequently used to increase the speed and quality of development activities. Microservices architecture is commonly used in modern software development, especially for large and complex applications that require scalability, flexibility, and the ability to rapidly respond to changing business requirements. So you can see in the diagram below how it looks like and how it gets managed independently, and each microservices could be managed independently, could be developed, deployed, and it can be managed independently. Then the key characteristics and principles of microservices and architecture. It includes service independence. So each microservice is a self-contained unit with its own code base, data store, and functionality, allowing it to be developed, tested, and deployed independently. Loose coupling. Microservices communicate with each other through well-defined APIs, but they are loosely coupled, meaning they can evolve and change without affecting other services. Single responsibility. So each microservice is responsible for a single business capability or function, making it easier to manage and understand. Technology diversity. So microservices allow the use of different technologies, programming language, and databases for each service based on its specific requirements. Uh, Coming to scalability, so services can be independently scaled up or down based on their individual resource demands, improving the system performance and cost efficiency. Resilience, isolation between service ensures that failures in one service don't cascade to other service. Redundancy and failover mechanisms can be implemented at the service level. And then continuous deployment. Microservices facilitate continuous integration and continuous deployment, CI/CD practices, enabling faster and more frequent releases. And then the centralized data management. Each microservice can have its own data store or databases, and data consistency is maintained through well-defined APIs and eventual consistency patterns, monitoring and observability. So microservices require robust monitoring and observability tools to track the health and performance of each service, diagnose issues, and ensure the overall system's reliability. Security measures, including authentication and authorization, must be implemented at both the service and the API gateway level to protect sensitive data and functionality. Organizational structure. The teams are often organized around microservices, with each team responsible for developing, deploying, and maintaining their assigned services. Then coming to testing. So comprehensive testing includes unit integration, and end-to-end testing is crucial to ensure the reliability of individual services and the entire system. Documentation. A thorough documentation of each microservice, including API documentation and usage guidelines, helps facilitate collaboration between development teams. Now coming to the monolith versus microservices application architecture, side-by-side comparison with different aspects. So the architectural aspect, in a monolith architecture, the entire application is built as a single tightly integrated unit. All components, modules, and functions share the same code base and resources, whereas in microservices architecture, the application is decomposed into small independent services, um, each responsible for a specific business capability. Each service has its own code base and resources. Then the next aspect is modularity. So monolith application tend to have less modularity, making it harder to isolate and update individual components without affecting the entire system, whereas microservices promote high modularity, allowing for individual services to be developed, tested, and deployed independently. And then the scalability. Scaling a monolith application typically involves replicating the entire application, which can be inefficient if only certain components require more resources, whereas microservices enable fine-grained scalability, allowing you to scale specific services independently based on their resource demands. And then technology stack. Monolith application typically use a single technology stack and programming language throughout, whereas microservices architecture allows for a technology diversity, meaning different services can use different technologies and language based on their specific needs. There are other aspects like data management, complexities, maintenance and debugging, efficiency, which you can read it through while stopping the video. And then the other aspect is development teams and the deployment aspect. So deploying changes to a monolith application can be complex, as updates may require deploying the entire application, potentially causing downtime, whereas microservices facilitate continuous deployment, making it easier to release updates to individual service without affecting the entire system. So that's all. Thanks a lot for watching this video.